Okay. Everyone, welcome to our first bite session of this term. Thank you all for coming, both here and virtually. We have a very special bite session for you today. I'll let him introduce himself.
I'm Orion. Yeah. I didn't know I was the first one. I'm honored. So I guess I'm doing Conda virtual environments. So some of you might know something already, some of you might not. So I guess just start, show of hands, who has heard of Anaconda? All right, pretty good number. And who's heard of virtual environments in general? And then who feels comfortable setting up a new virtual environment and installing a few packages into it? Perfect. Okay, that's good. So I'm going to basically go over the bare minimums. I'm not a super uber expert in this stuff. It's just something I have a working knowledge of, and it's super useful. If you don't, any of you guys that know more, if you want to know something that I don't, interject anytime. But my goal today is to show you how to kind of sell you on why you should care and give you the basics to get up and running if I convince you that you should care. That'll be the first challenge. So the first thing is to kind of clarify what problem these virtual environments try to solve. And so the key realization that every tool you use while you're coding is in fact code. Visual Studio is code itself under the hood. Python is code under the hood. And all of these things change over time. You'll see these version numbers kind of updating always and always and always. So Python 2.7 is very different than Python 3.9. That code has changed, just like your code bases change. And over time, as things change, some things break, especially when this code has to work with other code. Let's say I write my software to depend on the features of Python 2.7. Some of those features go away, then it's not going to work in Python 3.9. So sometimes my code has to work with specific versions of other code. And so it's kind of a hypothetical. Just imagine taking two classes that both use Python, and they both give you starter code. One gives you starter code that's all Python 2.7. Some lazy teacher that has 5-year, 10-year outdated code that doesn't want to update it, and they just tell, hey, go use Python 2.7, you'll be fine. And the other one tells you to use Python 3.9, something actually recent, modern, and usable. And so if you're trying to switch between these two classes, how might you do that? If you're working on one half-hour block, you want to go work on the project on the other, you don't want to be reinstalling Python or uninstalling and reinstalling a different version. And you can keep different versions and kind of switch between them in a couple different ways. There are other ways to solve this, but it gets a little bit more complicated if you have more dependencies or more packages. So think about class one, you also need an old outdated version of NumPy and of pandas, kind of these other tools that are really useful. But again, they have their own versions and you might need specific versions. So then you don't want to be manually changing all of those versions every time you want to switch over to work on a different class. And in real world, this happens a lot where if your team is working on a product and a new version rolls out, you might keep going with the old version just because you don't want to deal with switching over right away. Or for example, in my research right now, I'm using a really useful time series library for forecasting, but I have to use Python 3.7 if I want to use that. So it's very common that you're kind of forced to use certain versions of certain things. So virtual environments make it kind of the solution to the switching problem of how do you context switch between different sets of dependency versions. So they are a Python tool for dependency management and project isolation. So they help manage all of those dependencies. They help you keep track of all of those versions, keep all those versions organized and in one place, and isolated. So they help you kind of keep one project's dependencies isolated in this term of a virtual environment. And just to note, this is a concept that appears in all other languages. It's not Python unique. Python just is, in my opinion, a little bit easier than a lot of other languages to do this with, really friendly to do this with. And it's just super important, kind of the most, I guess, the best place to learn these concepts in my mind. Just kind of, let's see. And so yeah, there's a lot of tools to help you facilitate this. Python has virtual env, venv, Conda, pip has its own version, I think pip env. Even Google Colab kind of does this for you in a way. I'll kind of talk a little bit more about that as we go, but they're holding a whole virtual environment for you to run your code in, except they're just storing it on the server. It's not actually stored on your thing. That still is giving you an environment to run your code in. So my personal recommendation is Anaconda, just because it's, I think, the easiest to get up and running with. But any of these other ones, very similar. The concepts are all the same. YouTube and Google kind of tell you what commands are different. But just, I guess I'll walk you through Anaconda, but just be aware there are a lot of options out there. So just really quick note, most of this is going out on your own and figuring it out. Anaconda is a huge data science toolkit. There's a lot of stuff. Everything you need for, at least that I've ever needed from it, is contain what they call mini-conda. It's kind of a smaller pared down version of Anaconda. And you can install that from this link. I'll talk a little bit about how to do that, but it's really just walking through a GUI installer, just like you would for Chrome or any other application. You just find the version, download it, and walk through, and that'll get you all set up. The main thing that you need to be able to do is after that install, if I open up a terminal, I need to be able to type Conda and have my machine know that that means something. So it's saying, hey, Conda is a tool for managing and deploying applications. If it gives me like error, command not recognized, you haven't installed it yet. So that's kind of the first thing that you just got to get it to work on your machine. If you're having trouble, feel free to grab me on Discord. It's probably pretty simple if something's not working, but should just be walking through that GUI. So just to give you a little bit of a conceptual idea on what we're trying to do before I go too deep into kind of working with terminal. So imagine we're on this cool developer machine where we have Chrome, Visual Studio Code, all our stuff downloaded, as well as Python, Pandas, Matplotlib. So what we're trying to do is create a little box inside of our computer, a virtual environment inside of our computer. And let's say we want to use Python 3.9 inside that little box. And we want to have a different version of Pandas. We want to have a different version of Matplotlib. And we want to maybe install TensorFlow or some other tools, all inside of that little box. So we're going to create a virtual environment and go within that virtual environment and download all these packages. And so you really should think of it as it's a virtual computer in a lot of ways. It's not quite a full virtual machine. That's another concept. But when you're within this little box, if I run my Python program, all of the code it knows about is what it has access to within this computer. It doesn't know anything about anything outside, and anything outside doesn't know anything about what's in that little box. So it's a fully isolated component. So is that conceptually kind of making sense to people? Any questions on that? So diving, where did my slides go? I lost it. There we are. So going a little bit into what the commands are when you actually have Conda. This is a super basic cheat sheet of really, for environments, the main stuff you're going to need. This is all the stuff I really use with Conda day to day. You can click this link. I'll share these slides afterwards for a full cheat sheet. Even this one is just 2 pages. It's still pretty brief for what it is. But so there's a lot more stuff you can do with Anaconda, but all the simple stuff you should care about right now is right here. So what we're going to do is create a new virtual environment, activate that environment, kind of step inside of that box and step inside of that virtual kind of isolated part of our computer. If we want to deactivate it and step out of it, we can do that as well. There's a couple ways to install packages once you're in there. You can install a package by a certain version. And if for whatever reason I wanted to delete an environment entirely, I can do that as well. And that's really the bulk of what you need out of Conda. So we'll start by creating a brand new one. So clear everything out. So I'm in my terminal. Right here, I'm in Orion. I'm in my computer right now. Once I step within a virtual environment, this kind of command line will change. So let's say, I think a couple of you guys are in 4.3.4. Is that true? That was kind of the analogy I was running with, but any of you guys in 4.3.4 right now? One is, all right. You're gonna be my case study still. So I'll do conda create and I'll do CS 4.3.4. So I gotta give it a name. Dash name. I'm saying conda should create an environment with the name CS 4.3.4. And let's say we want Python equal to 3.9. That's going to go in and create that little box named 4.3.4. It's going to say, hey, you got to install this stuff. Yes, no, just generally say yes. Conda probably knows best. And it's going to go out, fetch whatever other packages it needs to kind of build this environment for you. And it will set that up. So we're creating that little box just to keep our picture going as we go. We have now named this box CS 4.3.4. We now have that little virtual environment on our computer being created. And so, yep, it's all set up. It's all done executing. It says to activate this environment, use conda activate CS 4.3.4. Oh, it looks like I have a typo there. CCS. All right, we'll run with it. So conda activate. We're going to step inside of that box now. CCS 4.3.4. That is going to bother me. And so now you'll notice my prompt actually changes. My terminal right here is letting me know, hey, you're inside of this CCS. It's already driving me insane. Okay, 4.3.4 environment. So we're now inside of that library. So if I step back out, I'll Conda deactivate for a sec just to show you something. So if I say Python, so now I'm actually running Python in my terminal. Like I can say print hello, print, not quite, print just like I'm in Python. If I try to say import pandas, for example, I have pandas on my computer. It's back to that diagram. It's on all the way over here. Pandas is on my base system, but once I'm in this environment, it doesn't know anything about my base system anymore. It's pretending that the entire universe is that environment. I haven't installed pandas. It's saying module not found, no module named pandas. So activate again. I want to add Python, add pandas in this environment. And I guess if you guys heard of pip install, that's familiar for you guys. You can use conda install. I prefer pip install. Either one works. Basically goes out and grabs someone else's code from somewhere on the internet and installs it onto your machine. So I can just say pip install pandas. And it will, again, take a little second to go collect that. It's going to run out, grab pandas, do everything it needs to do, install a couple other things, and we will now have pandas within our virtual environment. It will be accessible. So this does take a little bit. Pandas is a little bit of a bigger one. So you guys getting that isolation of how this is a totally separate part of my computer. So as far as my code running in this terminal knows, nothing on my base system exists except for what's in this environment. And so now we're all good there. So if I say Python and I go import pandas, it knows what pandas is. We now have access to pandas. So suddenly that is in my terminal. And so that's really the crux of virtual environments. If I'm running a script and I run it from this terminal now, while I'm within my environment, it will have access to everything that that environment has downloaded and nothing it doesn't. So if I'm trying to maintain those particular versions, I could say, hey, install this version of NumPy, install this version of Matplotlib. But as soon as I say conda deactivate, then none of those things exist anymore. Deactivate, rather. So you can have many of these things. I mean, I probably have 10 or 12 at this point. Most of them I don't use day to day, but there's 3 or 4 that I'll switch off between pretty often because I need different pieces of code. And so depending on what I'm running, I can jump into that environment and use it. Is everybody kind of clear on just from a computer sense what's happening? Cool. So one of the things I will show a little bit of is setting this up in VS Code. Some people hate VS Code, people love it. It's a really, in my opinion, well-designed, simple editor. It's a really good place to develop, just because it's user-friendly in a lot of ways. And so getting stuff up and running is kind of quick. So this is no different. When you're in VS Code, let me open up a project here. So I have a directory opened here. I just have a couple files in it. These are activity and a lecture from the 434 class. So you can tell VS Code to pretty much exist and run within an environment. This is a command that is in there, but it's Shift Command P. You can't get it to the settings, but what you want to do is tell which Python interpreter. This is kind of saying which Python environment do you want VS Code to use. So I'll search the settings, Python, select interpreter. It should give it to me there. Yep. And I had this huge list of all of those different environments that I've created. Let's see, where's my CS434 one? Oh, I might have to restart because I created it after I opened this. Sorry, 1 second. About that. Let VS Code think for a moment. Still thinking. And there we go. So from this list of interpreters, you can see I am very messy. I have too many of these on here, but CCS434 is now showing up. So by selecting my Python interpreter, I'm telling VS Code which of those boxes to operate within. When I click that, now any of my code in here, even if I import pandas, for example, it isn't going to give me a squiggly underline on pandas because VS Code, the debugger that's giving me a little squiggly saying, hey, I don't know what this package is, it is running within that environment, so it knows what pandas is. It has access to all of that stuff that's running within. If I try to say import, I don't know, Seaborn, like a graphing library, it's not going to know what that is because I haven't installed that within my virtual environment. If I go and pip install it, then it will have access to it from that point forward. So the other thing I'll show you a little bit on is these interactive notebooks. This is another kind of one of the selling points, at least the data science of using VS Code, is that they let you run these notebooks, kind of Jupyter notebooks, but on your local machine in VS Code. So kind of like we select an interpreter, you have to also select, oh no, I might die soon actually. Uh-oh. Oh no. Oh no. Yeah, I think that one. Truth. So similar to kind of selecting that interpreter, sometimes have to do redundant stuff here, but we'll tell it which kernel to use. So in this upper right-hand corner, it's really gonna be that same list, but I'm just telling it which set to kind of use for my interactive notebook. So just like before, I'm telling it, hey, which environment should I run this code in? So when I select that, we'll see, all right, we can load all these packages, all this fun stuff. If I hit try to run it, let's see what happens. Oh, I need to get a package. You can see it's not flagging pandas. Some of this stuff is just a built-in part of Python. Like Python's going to give you NumPy, it's going to give you SSL, but it doesn't give you any of this other stuff. It's just saying, hey, I don't know about what any of this is. I have no idea what matplotlib is, even though it's on my base machine. This virtual environment has absolutely no clue. And asking for a kernel. If VS Code tells you to install something, you generally say yes. Sometimes these notebooks have a little bit more setup, specifically a kernel. And so even the code to work this Jupyter notebook is something that it needs to install. VS Code is kind of clever enough to do it for you. It just takes a second to set up, but it doesn't know anything about how to work with this kind of file because your environment knows nothing about that kind of stuff. So it has to just grab all of that really, really quick. Run enter. Let's see if we can run all. Start to run all. So it's going to think for a second, and then this is kind of the classic error you're going to run into when you're getting set up, is it says, hey, I don't know about this thing called matplotlib. And so whenever you get that error, your immediate response is, okay, pip install whatever you told me I don't have. So it says you don't have matplotlib, then I just straight away note I'm within my terminal, or sorry, within my environment, CCS 434, pip install matplotlib. And that will take a little bit of a second. It goes out and grabs that code, and then it's going to know what matplotlib is. So it's really just running this code, trying to say, hey, I can import that. Yep, no problem. I can import NumPy, no problem. Pandas, no problem. But this isn't in the virtual environment, so I don't know what to do with that. But now we just installed it, so we say run. It should get past matplotlib, but it's probably going to break on one of these other ones it doesn't have. Oh, no module named Seaborn. Okay, pip install Seaborn. This is a very, very common flow. If you go out and grab someone else's code, trying to get something up and running, just whatever it doesn't have, go grab it. Seaborn will take a little bit of a second. Some graphing library. You should start to kind of see the flow here of I need to grab all these packages. And you generally do a lot of these things once because you're doing the same kind of work. Like for 434, for example, I set up a directory in an environment with all of the lectures in it, and most of those have the same packages. Maybe you get to the 11th one and you need some other graphing library. No, I got to pip install that. So this gets very, very rare. But when we're initially setting it up, it's going to be anything we don't have is going to break it. So I think it should still need sklearn. Yep, no module named sklearn. So I go pip install sklearn. So I'm adding all of these things into that little virtual box and make it so that my code can do what it needs to do running within that virtual environment. And I think that's everything we need. And it's running. So it should be able to run all from there. So yeah, sorry for the little hiccups on the power cord, but is that making sense on how this kind of workflow of I don't have this thing in my environment yet, I need to add it to my environment and then carry on. And then once you have everything installed, it should work. If I tried to, again, it's only what is in that little box and you need to add everything you need. It's kind of like you're redoing it from scratch. You get to have really fine-grained control for what you do and do not have. Any questions on VS Code integration? And this can be a little bit finicky, so sometimes before it's asking questions, something comes up or Google's your friend, but yeah, that makes sense. Yeah.
I'm just curious, can you access all of your virtual environments?
Yeah, so it depends which one you're using. So if you're using VENV versus virtual ENV, sometimes you'll save a virtual environment in a specific directory. That might be useful if, say, you're sharing code. There's different ways you can actually pass these environments or pass compressed versions of these environments, like the requirements list, in your directory to move around to another computer or to pass to friends if they can recreate that environment on their machine. But something like Anaconda, it just lives in your root directory, so it's accessible anywhere. Yeah, it's the same ones are, it's kind of Anaconda has their own folder containing all of those environments. So it's accessible from anywhere.
So does Conda use like is it or requirements? Like if you're like in a GitHub repository, what's
Conda,
keeping?
they have a .env file. You can do it from requirements.txt. So kind of getting back to if you're trying to move, let's say I want to have my Conda environment and I want to save it, bundle it up, store it in GitHub. So if somebody clones my code, they can recreate that Conda environment on their own. There's multiple ways you can do it. Kind of a requirements.txt file is pretty common. So you basically just say, hey, Conda, give me a list of all my requirements and my version numbers. And it'll just list them all out. Pip can do the same thing. Pip list, give me a list, anything I've installed. And then I can say, Conda, go install all of those things all at once. That one's a very general format. It's the text file of requirement equal to the version number. That's super, super common. Conda has a little bit of their own proprietary one where it's I think it's a .env file, where it basically compresses all the dependencies of your virtual environment and makes it in kind of a loadable format. You can say create Conda. There's some command in Conda create that will let you load it from one of those files. Rather than creating one that's from scratch, I'll create it from this .env file. We're getting back to you. I'm guessing it's JSON or something under the hood, but yeah, they have some, they're not passing out everything, but usually installing some requirements list more or less. But
no, that makes sense. Yeah, I just asked because I know 50 these like fit file.
yep. Yeah, and it's more, I mean, you can do a requirements.txt in Conda as well. No overlap, super heavily. But yeah.
Yeah, I was a little curious. It sounds pretty similar to like Docker. I was curious about the big similarities and differences between the two.
Yes, I'm not the best person to ask on that. One of them might know more about containerization. The big thing is this is lighter weight. This is super, super minimal. All that you're doing is you are containing your dependencies into one place in a way that you could recreate somewhere else. Docker is grabbing, somebody might have a better definition, but it grabs more than just your dependencies. It's kind of your entire environment settings. Like it simulates, I guess, yeah, you have better words for
I
this.
don't know if I have anything better, but I think Docker is kind of more like heavyweight, like you're putting an entire application into an entire server, like an entire program. Versus like, little pip environment or Conda environments are like, your tiny little project, more like a dev environment type of thing that you're like when you're developing versus like I think Docker is a lot more like your production environment, like our things, like our entire business is running. It's like my very high level of business.
We'll tie in more things than just Python dependencies. So this will
Yeah,
only work for the Python file. For example, within a Docker, you could have some bunch of Python code that does some functionality. You could have a C++ component that does something else for you. You could have some networking module that someone else wrote. You could have something else you wrote in-house. You could have like a tool that is a black box you don't actually have access to the inner code of, but you're just using it like it is. And it is able to package all of those things up. It is in a similar way. There's a very similar concept. It just packages more all-encompassing, and it makes it a little bit more complex to get going with, and it's definitely not as quick.
Yeah, okay, I see. So if I understand it, then we're gonna have our Anaconda here, so it's very like specialized, but very fast and easy to get to immediately. Then we're gonna have, we wanna move step up, generalize a bit, maybe have a whole thing, something that a server can basically like, we'll go up to this Docker container, and if we need more, we can go full-fledged, yeah, at that point.
Yeah, I think that spectrum is, yeah, I would agree with that. That's
Thank
a good way to summarize it. Yeah, and containers are, you might know better, but they're a muddy concept for me. It's one of those buzzwords that's
Well,
never
I mean,
gotten.
even Docker, I mean, it's that there's a bunch. But I mean, I think in general, Docker is kind of more, I mean, that's like large scale, like you're a company with big teams, like we're trying to manage a whole bunch of like big pieces versus like something small. Like this. One little.
Deploy a system, not run a file.
Exactly.
Yeah, thank you.
Mhm.
Any other questions?
Mhm.
This is description of chemical analysis to determine the origins of wines. You got alcohol content, malic acid, ash, alkalinity of ash, all these different things. I think the goal was to predict quality of the wine based on a measure of price to see if price actually have any indication of what's in it. I think was Patrick's vision here. Yeah.
Libraries using Anaconda versus in your own environment versus libraries. Where are those libraries physically installed?
Yeah, so Anaconda is kind of abstracting that away from you, but ideally you don't have to care. Once you're in your environment, you have access to it. In reality, if we go back to selecting our kernel, you should be able to see there's a big, long, it has closed caption right in the way of it, but all of these have a super long path. It's somewhere in the root of my system /OPP/miniconda 3. So within Anaconda, within ENVs, within the environments, I have test. I have within those ENV, I have CCS 434, and then within that directory is where everything gets installed. So I think Python requirements go directly into Python/bin. Is that true? So with wherever Python gets installed, all my Python requirements are kind of in that directory. It's actually installing a full version of Python into this 434 folder. And then it's telling, hey, VS Code, when you go for your debugger and you want to check which things to put a squiggle under, you should check based on this path. When you want to run Python, you should use the Python at this path. It's really just changing one path somewhere in your settings for VS Code. When I select this kernel, it is setting the path to Python. It's saying this is the path you should use to run the Python program on your computer. And that path is all the way in here at ops/evs/ccs434/bin/Python. So it is just stored on your computer somewhere still. So that diagram I drew isn't really true. It's not going into some magical partition on your disk. It's not actually separating out part of your file system, but it lets you pretend a little bit. So that's kind of the magic, is it gives you this nice abstraction. You can think about these separate environments, but under the hood, it's just really organized file paths, keeping track of where things are. Yeah, good question, though.
I have a question. So about that, does this mean that like if you have two different environments that use the same version of Python, it'll only store it once, or will it have to like store it twice?
It will install a brand new copy. So if I guess won't bother going through, but I could say Python create a new virtual environment with Python 3.9, the same one I just did. I mean, you can see how many copies of Python I have.
Right.
I should probably go through and clear out a few of those. I still have a Python 2.7 sitting in there somewhere, which is years old. I haven't ever used that I know of. It's probably whatever came stock on my computer. Yeah, and so normally your computer is going to use like user bin Python 3, but you can have as many Python versions you want. Really, you could have every version ever installed on your machine probably at once if you have enough storage. But yes, it creates a full new install of Python. It's a completely separate thing.
Thanks.
Wow. Good questions? I'm happy to help set this up. I think it's super, super worth doing, especially if you're doing data science 434 stuff. Colab, I guess to kind of circle back to that. So Google does this for you if you run a Jupyter notebook. You guys used Colab before? So that's creating a virtual environment for you. It's that same thing. They're just doing it on a Google server somewhere. And you're running all your code in that virtual environment on that server somewhere. And so it lets you not really have to think about any of this because it does it all for you out the box. But there's a lot of advantages to running code locally rather than Colab. You have full debugger. You can actually step through things line by line and look at your stack call and do all these more advanced features that are really helpful in developing code that Colab will just never let you do. And even going from using Jupyter notebooks to using this VS Code thing, if you get your VS Code debugger in interactive notebooks, you get to all those more advanced developer features are kind of available if you can bring these things locally and have more control. So it's really worth doing if you're willing to deal with the setup. Any other questions at home? I haven't checked the chat.